Good afternoon, everyone. It's my pleasure to welcome all of you here. This is Urban Science and Planning Lab series. It's part of my research groups. It's not only my research groups. It's part of the Urban Science and Planning Centers and belongs to the CAUP and our College of Architecture and Urban Planning at Tongji. And now, last year, we just upgraded these research groups to Sano UK joint labs with UCL. So we have many topics about urban science. And the reason why we pay more attention to the urban science is only we see the necessity of empowering the current planning practice or the planning research with the kind of more scientific thinking. The scientific thinking is in different kind of formats. I think this is in Tongji, we have many faculty members, for example, Professor Diao and Liu, and we have many other staff. This afternoon, some of the PhD student has been occupied or is all well kind of equipped by the methodological workshop there, and which is led by Professor Wang De. So I think this we all see the necessity of seeing or knowing what happens about the cities with more scientific views. Today, we are more than happy to have Philip here. Philip is just writing stars. I think most of you, I just got some many messages right after posting this in my WeChat moments. And many of the messages from other universities and well-known scholars. It's not only from the students. So we do see that Philip's work has attracted wider attentions from the whole China. And this is also produced by these well-known groups and lots of groups of people from China as well. So I think that that is real kind of achievements. Last year, I think, is that last year? I think last year we met at Tsinghua.
Yeah, last year.
Yes, that's the very end of last year. And we have a journal. I have a journal with Professor Long Ying in Tsinghua. We have a journal called the Transactions in Urban Data Science and Technology. We have a kind of regular workshops. And this year, we have an extensive workshop in Tongji, in the second half of this year, and we will extend to Hong Kong University later. We met Philip and we met Fabio from MIT as well. So we do see that they have developed a very good research units in these two universities. So Philip's works covers many topics. It's not only about the 3D GIS. The 3D GIS is where I know and where Philip started his career in TU Delft. And Professor Liu is also part of it in the 3D GIS groups. And Philip, of course, extends his scopes to the more urban analytical things, and particularly for the street image. I think as you can see all these pictures. So let's welcome Philip for his wonderful talk. And I do think that you will learn quite a lot from this all slides. And this presentation has been well prepared. And Philip just told me that it will last nearly about let's say 60 minutes, maybe. Yeah, it's more than 60 minutes. So he just continually editing his slides until this morning. So let's welcome Philip. And but very first but not the least, and thank you very much for joining us.
Thank you. Thank you. Good afternoon. Thanks a lot, Professor Shenyao, for hosting me here. And I'd like to spend the next 1 hour to introduce you to the work of my research group that is covering urban informatics. I'd like to cover different projects that we have been working on in the last few years, and I also like to cover a bit about our philosophy of research and research agenda. And actually, I'm here in Shanghai on a holiday, but I know many people at Tongji, like also Professor Liao, Professor Liu, so I cannot come to Shanghai without dropping by here. They would get very angry. And it's really a pleasure and honor to be here. Your college is actually quite famous and well respected at NUS, and we hope to always have continuous new collaborations. And I also really like many things in Shanghai, and I'll be happy to be back when I can. Like yesterday, I went to the urban planning exhibition. The efforts done here are also really impressive, and I hope to be able to learn more. So I'd like also to introduce myself a bit. So my background is in geomatics. I actually don't have a background in architecture or urban planning. And I started my academic career at TU Delft. I worked mostly on 3D GIS. And actually, this guy, maybe you recognize him, is Leo. We did our PhD together. Maybe you will not really recognize us because we are much younger here. This is before we started working on our faculty. But yeah, we did our PhD together, and it's really nice to see him again now in a different role. And yeah, after I finished my PhD at TU Delft, I moved to Singapore, where I joined two departments. One is real estate, the other one is architecture, focusing on urban planning. So I'd like to introduce you a bit to my university, in case you're not familiar. So we are the largest university in Singapore. We are one of the 6 publicly funded universities, and we are the most comprehensive one. So we have 17 schools ranging from medicine, dentistry, all the way to social sciences, music, and engineering, all different kinds of engineering, and so on. And one of these schools is my school, the College of Design and Engineering, where my department is accommodated. So I come from the Department of Architecture. That's my primary department. And the name doesn't do it really justice because the department covers a whole range of domains very similar to your college. So it's not only about architecture, but also about landscape architecture, urban design, urban planning, and so on. And we have more than 100 faculty, full-time and adjunct, that come from more than 14 nationalities. We also have a big student cohort. We have more than 1,000 students, and we also have a PhD program covering all this topic. And when I joined this department many years ago, I noticed there is a significant gap on urban analytics. So there has not been any research group focusing on the topic of urban analytics. And 6 years ago, when I started this job, I decided to start a research group called the Urban Analytics Lab. And the last 6 years have been quite a nice journey, thanks to many of our staff and students, both present and past. And I would like to share a bit more about this journey in the last 6 years. How did it all start? What is the motivation? And what are we doing actually? So at the core of our research group, we have people. We have about 20 full-time researchers. And people are, of course, our key ingredient to our approach to urban analytics. They come from different backgrounds: geography, transportation, architecture, planning, computer science, even biology. And we decided immediately at the very start to focus on multiple disciplines. We didn't want to keep working in urban informatics, focusing on only one topic like real estate or maybe urban climate. We wanted to cover a wide range of domains like transportation, thermal comfort, urban climate, urban design, and so on. So the main ingredient to our approach to urban analytics is multidisciplinarity. And our research is supported by 20 full-time researchers who come from many different domains, and they work on many different research directions. And in the past years, we have published different research on all these topics, covering like urban morphology. For example, the image you see in the middle is a map of Singapore, where we mapped all solar panels. So we work also a bit on renewable energy as well. And at the bottom, there is a map from one of our recent research that investigates visual complexity in cities. Another ingredient is that we don't focus only on urban informatics, but we do it with a strong geospatial foundation. So when I started this group, I noticed there is a knowledge gap. Lots of people, they have a lot of domain knowledge. They rely a lot on spatial techniques. They rely a lot on spatial data, but they do it often without understanding where data comes from. They do it without understanding what is actually the quality of the data. And conversely, we also have a problem. We have often people who are purely in GIS science. Of course, they're experts in GIS. They know everything about data standards. They know how data is collected, but they don't really know how data is used. So they lack domain knowledge in urban climate. They lack domain knowledge in real estate and so on. So the goal of my group is to bring these two silos that are traditionally disconnected together under one roof. So we decided to pursue an agenda that is focusing on urban informatics, but doing that with a strong geospatial foundation. So we also do research on spatial data quality assessment, on advancing spatial data acquisition techniques, and also we do a bit of research on spatial data standards. For example, I'm part of the Open Geospatial Consortium. I work on developing new standards. Another ingredient is localizing our research. So we are based in Singapore, the heart of Southeast Asia. And Singapore, like many places, has its own challenges. It's quite specific. One of the specific things about Singapore is that it's one of the smallest countries in the world. So I overlaid the outline of Singapore on the Shanghai area. So Singapore is a country that is smaller than your city. And you can imagine there are lots of challenges like lack of space and so on. Another challenge that is specific to Singapore is that it's based on the equator, meaning that it's always very hot and humid. So topics like urban climate, thermal comfort are quite important. And Singapore is also a city that is investing a lot in different initiatives in urban planning. For example, it has excellent programs on urban greening, and all that warrant research that is specific to Singapore. And also because in Southeast Asia in general, we lack research on urban informatics, we also wanted to cover Southeast Asia. So a lot of our research is specific to Singapore and our region. Another ingredient of our approach to this research is that we focus mostly on new kinds of data, those data streams that are emerging. So there has been a lot of research that relies on remote sensing, on satellite imagery, for example, but we think there is a lot of value exploring continuously emerging data streams. Primarily, we focus on street view imagery. We are working on inventing new applications, and also we work quite a lot on volunteer geographic information. So not only crowdsourced initiatives like OpenStreetMap, but also new kinds of crowdsourced data that have not been investigated before. I'll say a few words about that in a bit. And another important ingredient in our agenda is that we noticed that we lack tools and we lack data in research. Urban planners traditionally, and mostly, they're not always very technical, and they often lack tools to conduct different kinds of analysis in urban informatics. And we decided to not only just write papers, of course we have to do that to keep our job, but we also decided to invest a bit of effort in producing tools, primarily code and data that we can share openly with the community so people can finally get some concrete practical tools to work with. So in the past years, we have developed some data sets, and in particular, open source software that became quite popular and useful in the community. For example, ZenSVI is one of our latest software projects. And VoxCity is a completely new project that we have just released last week. VoxCity will be quite useful for those who work with 3D GIS because it's an open source tool that allows you to conduct the whole 3D GIS process from start to end, from downloading the data, generating 3D models, and using it. So In the next 55 minutes, I'd like to try to make sense of all this. I'll try to show you different examples of our papers, how all this comes together. And I'll start a bit with volunteer geographic information or crowdsourced data. So we realized that VGI has a lot of advantages. Traditionally, in urban planning, practitioners and researchers, they rely on government data, but we think there is a lot of value in crowdsourced data because often they can complement official data. And we use VGI for many reasons, and we also conduct a lot of research on VGI. So we are not only users, but we also work on topics like understanding the quality of VGI. And why we focus on VGI, often it can be of really good quality. For example, this screenshot is actually from here, from your campus, where the OpenStreetMap data is of really high quality. So on its own, this data can often be quite good. And OpenStreetMap is not really the only source of this data. There are many other crowdsourced initiatives that I'll be happy to talk about more. And when you have VGI, when it's of good quality, you can do a lot of new interesting things. For example, this is a paper we published last year in the US. It's the first approach to mapping urban morphology using unsupervised learning. So we focus on a couple of cities where we have really good data on building footprints from OpenStreetMap. And we developed an approach that automatically detects different categories or clusters of the urban form. So here are some examples for Singapore and San Francisco. And we also conducted the same analysis in Barcelona. So this kind of research can be powered entirely using volunteer geographic information. However, this data is not always of great quality, and there is often a lot of uncertainty about it. And this is where our core GIS science expertise come in. So we focus on topics like quality assessment of data, and also how to make spatial data better and more accessible. And this is in particular important for VGI because this data is not always perfect. Often we have a lot of data gaps, especially across Southeast Asia. This is an example from Indonesia, where you have all roads mapped, but buildings are almost entirely unmapped. So more than 90% of buildings are missing from this platform. And that means that in areas like this, we cannot conduct those kind of research that I have just shown you, because we simply lack data. And then we started working more on this topic to understand what is the quality of OpenStreetMap data around the world, and what can we do to make this better? Is there something that we can do to mitigate these data gaps? And then we started GenMapper. It's a project that eventually we published in IGGS. We developed a pipeline that relies on GEM, taking a feature that is well mapped to predict another urban feature like building footprint that is almost entirely unmapped. So we train models that take street networks as input. Street networks are almost everywhere very well mapped in order to predict building footprints in a way to attempt to mitigate these data gaps and allow practitioners and researchers to finally conduct studies in areas where this data was not available before. And GenMapper performs relatively well. So we conducted experiments in different areas around the world with different kinds of urban forms. And we started working on filling data gaps. This data, of course, is not perfect. You can see a comparison here between what is generated and the ground truth. But we think it performs relatively well for some applications where you just need the general urban form. And we released also the code openly, so you can run it from GitHub. However, OpenStreetMap is not the only form of VGI. In fact, in our work in the last years, we identified that there is an increasing number of data streams that are crowdsourced, but are almost entirely ignored. And one of these crowdsourced sources are accommodation reviews. So we've been working on identifying new kinds of crowdsourced data that have been entirely ignored to try to make sense of them, to understand if they have any use in urban informatics and what is their quality. Airbnb reviews are a really good example. I think most of you here know what Airbnb is. And when people are done with their stay in the accommodation, they can leave a review. Similarly, like they can leave a review at a restaurant or hotel they stayed in. And typically, guests, after they come back home, they leave a review overviewing the quality of the accommodation and the quality of the service and host. But we noticed that sometimes guests talk about the neighborhood. So they don't focus only on the accommodation, but they talk about the surroundings. For example, they write things like, I really enjoyed the stay in this home. It was very clean, very comfortable. The host was very nice, but I didn't like the neighborhood because it didn't have many amenities and I couldn't really walk to the metro station. So in this research, we have built a pipeline. This was before LLMs became popular. We built a pipeline that detects when people talk about the neighborhood and then focus on that and then measure the sentiment. And we published this a few years ago in cities. We focused on a few cities around the world that are popular among tourists. It was New York City, London, and Singapore. And we focused on 5 aspects that are frequently mentioned in these accommodation reviews, like amount of greenery, public transportation accessibility, crime, noise, density of amenities, and so on. For example, people were leaving reviews like, I like staying in this house. The bathroom was really nice, big, clean, but I didn't feel safe walking back from the train station. It was a bit of a shady neighborhood. So we identify all these pieces of text, and because we are dealing with millions of reviews or thousands of listings, we can basically introduce a completely new way to sense how visitors perceive cities, only from accommodation reviews. So this is one of our research directions. We are always looking into identifying all these crowdsourced data streams that have been completely ignored, that no one really talks about. But what has kept us mostly occupied in the last few years is street view imagery. So this is a relatively emerging data stream that we have been focusing on since the very start of our research group. And we like street view imagery quite a lot in urban informatics because in comparison to traditional sources of spatial data like satellite imagery, we get a new perspective in the built environment. So we get images from the pedestrian point of view, revealing some insights that are not possible with other kinds of imagery like satellite or aerial images. And we like street view imagery also because when coupled with computer vision techniques like segmentation, we can unlock many use cases and we have many more opportunities to discover. For example, we can use street view imagery to map the urban form. This is a map of Singapore that indicates the sky view factor. It's something that is actually quite easy to deduce. You just need to run an image segmentation algorithm, measure how much sky or greenery is visible at the image, and then aggregate that at the city scale. And this data can be quite useful for many different domains like urban climate, real estate, transportation, and so on. Another popular use case on street view imagery is something that may be quite relevant to you here at this college because it's related to urban design. It's perception. So like many other research groups around the world, we have been using street view imagery to understand how people feel about the design of streets. So how safe how beautiful, how depressing a street looks like. And we have been conducting surveys that measure the perception of people, and we have also been training machine learning models that do that automatically. And in the past years, we also introduced some new use cases. One of them was in collaboration with Shenzhen University. We found a way to predict soundscapes from images, so we can create maps of cities that indicate noise intensity and soundscape. And something that has kept us busy lately is comparing images taken from different time periods to map physical changes in cities. So street view imagery is not so new anymore. Now it's been around for more than 10 years. For example, here in China, Baidu started collecting data more than 10 years ago, and they've been collecting data every few years, meaning that we can use all data, compare it with the latest available images, and have a new way to sense changes at the street level. And something that my research group also started is nighttime data. So you know how satellite images can be taken during the night. Nighttime data became quite popular across many disciplines. There are even some data sets that can be downloaded on nighttime data. China also has satellites, and I don't remember exactly the name of the data set, but we also have been using that data. But images taken during the night from the street level are almost entirely unknown. So we started working on nighttime street view imagery to introduce a counterpart of nighttime light data from the pedestrian point of view. So we've been collecting nighttime data from the street level in Singapore, and we've been working on introducing new applications. And as part of this research, we have used data from the Chinese satellite. So I really cannot remember the name, but we've been looking how these two interact to understand what is the value of collecting this data from the ground level in comparison to the satellite nighttime data. And we like street view imagery also because it comes from different sources, not only commercial sources like Baidu or Google, but also we have recently an uptake in crowdsourcing this data, so anyone can collect this data and share it. And also governments started to recognize this data source as useful. So we have national mapping agencies around the world that started investing in collecting street view imagery and started maintaining this data. For example, all these are from Singapore, from the same street, but collected by different actors and different platforms. For example, in Singapore, we have a government agency called the Singapore Land Authority, and they started collecting this data on behalf of the government. So in the past years, that has been keeping us quite occupied. We are very excited about this. We want to know how can we use this data. We want to invent new applications. We want to explore what are the new use cases we can introduce. And one of the recent projects that we have finished is called Microclimate Vision. So in Singapore, urban climate research is quite popular. But one important gap in urban climate research is measuring microclimate. So you can put weather stations across the city. For example, you can put a weather station here to measure the temperature. However, we are limited by the number of weather stations we can place in a city. Not only because it costs money, but it's also a bit difficult to maintain them and find space for them. And this is a problem because if we measure microclimatic parameters here, like temperature, humidity, wind speed, and so on, they may be quite different from another location that is just 1 or 2 blocks away. And you cannot put an unlimited number of weather stations in a city. That's not feasible. And this is quite important because often, even at a very short distance, like a few hundred meters, the microclimate can be quite different. For example, this point here, just a few blocks away from our weather station, can be 2 Celsius degrees colder or hotter, even though they are very close to each other. So in this project, Microclimate Vision, we have been working on using satellite and street view imagery to predict microclimatic parameters. So we have been working on finding what is the delta between the measurement at a weather station that is nearby and the location. So we built some machine learning models that predict 4 parameters: temperature, humidity, wind speed, and solar radiation. And that enabled us to create high-resolution map of neighborhoods that predict these 4 parameters, primarily temperature, at a very high resolution, anywhere where you have an image. So these maps indicate the values of all these predicted parameters at the scale of our campus. And this research enables us also to understand what are the cool spots, what are the hot spots in the campus, and focus on them for interventions. So street view imagery has been around for quite a while, but projects like this demonstrate that there are still lots of opportunities to be discovered, lots of new use cases that can be introduced. Another new use case that we have introduced is more related to urban design, identifying what are typical street designs in a city. So we built an unsupervised machine learning approach that takes all images in a city. In the case of Singapore, we have about 200,000 images. And we got back 6 clusters, 6 typical streetscape designs in the city. We have conducted this for Singapore, and because we do it at a city scale, we can create maps of cities that indicate the spatial distribution of these clusters. For example, you may notice this area here. This is more cluster 1. This is the central business district of Singapore, which is most like this. So this is a completely new way to analyze streetscapes and cluster them into categories. And so far we have done this only for Singapore, but it can be transferred to other cities as well. And change detection is something we started to work on. There has been a lot of development in remote sensing to develop new techniques to detect changes in a city. But with street view images, there has been almost no research done. So we started working on this topic a few years ago, and we found that street view imagery can help supplement remote sensing techniques in identifying some changes that remote sensing techniques miss, some subtle changes like quality of the pavements, quality of facades of buildings, change in the vegetation at the street level, and so on. We don't have much research published on this yet, but we already started applying these techniques on the research I have just shown you about clustering different designs. So we compared images from Singapore in the span of 15 years. So Google Street View started collecting images in 2008 in Singapore. We compared it with the data from 15 years later, and we compared how these clusters have changed. So some streets have changed so much that they moved from one cluster to another because they got more greenery or they got more construction going on and so on. And all this research is cool, but we cannot do much if we don't have tools. So we identified a gap that in the community, we really have a desperate need to have open source software to support this kind of analysis. So a few PhD researchers in my group started to develop their own software to support their research. And eventually, they reached a stage where they were happy to release it openly to the public. And one of the examples of these initiatives is urbanity. So this is a research prototype that was developed by Winston, one of our PhD students. It's a completely new way to conduct network analysis. So he developed a street network analysis tool that embeds data like street view imagery that has never been used before in network analysis. For example, we calculated the amount of greenery for every street and embedded this into the network analysis. And this data set, this software is released open source on GitHub. Anyone can download it and use it for a new way of network analysis. And together with the software, he also pre-computed these indicators for 50 cities around the world for those who don't want to run his software. So we released an open data set as well out of this project. And thanks to this software, we can conduct network analysis that take urban morphology, streetscape indicators, and so on, while understanding networks in cities. For example, this is a neighborhood in Singapore. And thanks to his software, he analyzed what people see when they move through different routes in the neighborhood. This paper was published in EPB a few years ago. Another piece of software that we have just released a few weeks ago is NSVI. So when you see so many papers using street view imagery, you may think, oh, there must be some really cool software that people simply use, and that makes all these analyses quite easy, but that's actually not true. Actually, there has been no software to conduct these analyses, and this is a gap that we identified. And finally, one of our PhD students, Koichi, he decided to implement a Python package that supports these analyses from start to end. Start meaning it helps you download this data. It helps you analyze the metadata, quality of the data, coverage. Then it helps you to run some transformation and computer vision approaches. And finally, it helps you conduct use cases and visualize the results. So this software is a product of a few years of work, of hard work by Koichi, and now it's finally done. ZenSPI is available openly on GitHub. You're welcome to download it, but also you are welcome to check out the paper we just published in CUS about this software. So we don't want to conduct only studies, but we think there is value in focusing on other types of academic output like open data and open source software. And in urban informatics, we identified there is this important gap. We simply lack tools to conduct studies. And this is quite an important technical barrier because in urban planning, not everyone is technical, and not having ready-to-use tools is a significant barrier to entry. And another gap we found is that we lack GIS science research in all this kind of new data. For example, there have been hundreds of papers that use street view imagery, but they all take data for granted. They never discuss quality. So we have been working on understanding what is the quality and reliability of street view imagery data. And a few years ago, we conducted a study that establishes the first standard for assessing the data quality of street view imagery. We identified 48 quality elements, the standard geospatial data quality elements like completeness, but also we identified some completely new things that are not covered by existing standards, and we put them together in a framework. And now this work is adopted by ISO, and it's going to be part of the ISO 19157 standard for assessing spatial data quality. So, as I said, we are quite into crowdsourcing. Yes, companies like Baidu, companies like Google, they've been doing an amazing job sending all these cars with nice equipment, taking images. They collected hundreds of billions of images. But because we are into crowdsourcing, we wanted to focus also on understanding crowdsourcing street view images. And we think this is quite an important topic because when you read papers in the field, almost everyone is using commercial data. So street view imagery can come from different sources, not only commercial, but it can also come from governments. It can also be crowdsourced. And yet, when you read papers, almost everyone is using commercial data. Papers that are coming from China, 99% of them use Baidu Maps or Tencent. Papers that come from Europe or US, 99% of them use Google Street View. Only just a small fraction of them, they use crowdsourced data. So we found that gap really interesting because there are billions of crowdsourced images, but people are not really using them. So we were wondering why. And for those who are new into this topic, you might wonder, how is it even possible to crowdsource street view imagery? So actually, it's been quite popular. It's been like a counterpart to OpenStreetMap. So there have been platforms like Mapillary or CartaView that allow anyone, anywhere around the world, to collect images while moving. So there are volunteers that place smartphones in their cars or dash cams, or they place smartphones on their bicycles, and they collect data while moving. And at the end of the day or at the end of the week, they deposit these images on platforms like Mapillary and CartaView. And now, as a result, we have billions of these images shared by many volunteers around the world that are completely free to use. And yet, when you read papers, no one is actually using this data. And this is also quite interesting because this data can be sometimes even better than commercial data. Like, this is an image I found from Mapillary collected here. It's taken by a pedestrian, and this is not something you will find in commercial data sources. So sometimes crowdsourced data can offer us a perspective that is not available anywhere else. And yet, you will not see real papers using that. And in many cities, when you compare commercial and crowdsourced data, often you will see they look almost the same. One is commercial, one is free. The free one, the crowdsourced one, can be used for any purpose. You don't need to ask any permission. You don't have to pay anything. But yet, all papers use commercial data. So we got really interested into this line of research. So we started working, digging a bit further to answer a research question that has kept us also busy in the last few years. Should we start transitioning to crowdsourced street view imagery, or should we stick to commercial data like Baidu or Google? And on a superficial look, there are lots of advantages. This data is free. It's actually very similar to the advantages of OpenStreetMap. So it's easy to access. There are no license issues. The quality is heterogeneous, but it also means that some images can be of very high quality. Because anyone, anywhere can just, wake up and decide to collect this data. This data is not coordinated, meaning that it's continuously collected, meaning that some streets can have newer data in a crowdsourced platform than commercial data. So usually when Google or Baidu, when they collect data, they make a coordinated plan. They send a fleet of cars. They map all the streets at once. And then they come back only a few years later when the environment has changed. But crowdsourced data is different. Similarly, like OpenStreetMap, anyone can collect data at any time. So it means that some streets can be updated more often than commercial data. And yet it's not really used. This is an example for one city in Myanmar. So as I said, Southeast Asia is very important to us. And we found that in Southeast Asia, in some places like in Myanmar, you can find towns that are mapped in crowdsourced platforms, but not in commercial ones. So this is a town in Myanmar that has never been visited by Google. There is no Google Street View coverage, but you can find crowdsourced data. And there are other interesting examples, like we found images from North Korea, from some places in Africa that are completely left ignored by Google. And also, you may be familiar that Germany is a bit complicated when it comes to Street View imagery. So for many years, they didn't allow Google Street View to collect data, but there were no such restrictions for crowdsourcing. So anyone could collect this data. So in Germany, you can find better data often in crowdsourced platforms than in commercial ones. And again, this data is not really used. Another advantage we found is that because anyone can collect data from any transportation mode, often you can have some perspectives and platforms that are not available in commercial data. Like people collect this data while walking. This is an example from Tokyo. And this is something you will not really find in commercial data. Yeah, this is from Singapore, for example. Data collected while walking. And there are many examples, especially in Southeast Asia. Like, I don't know how many of you have been in Indonesia, but Indonesian cities are full of these very small alleys where cars cannot go, meaning that they're completely left out from Google Street View, but they're often found in crowdsourced platforms because people collect this data from scooters or bicycles. Parks and open spaces. So many of you are studying urban planning. You may be quite happy to hear about this, that open spaces can often be quite well covered in this kind of data. But then we realized actually why this data is not really used and why people still prefer to use commercial data is because of the equipment used. So because anyone can collect data using any kind of equipment, meaning the data can often be quite messy and not standardized. So this is supposed to be an embedded video, but unfortunately this is in PDF, so I cannot show it. But basically the main obstacle is that often this data is not collected from panoramic images. It's often collected from smartphones or dash cams, meaning that you don't have a 360 overview. And we found that to be a major deal breaker for researchers because they've been using panoramic images for many years and they don't see any reason to move to perspective images. And panoramic images collected by platforms like Google Street View and Baidu Maps, they offer an immersive and complete overview of the built environment. You can get panoramic data that give you a full overview of a street. And this is something that is not possible if you're using crowdsourced data collected from smartphones because you only have perspective images. And as a result, they give you only limited insight in the streetscape. And then we didn't want to give up from this data. We still think it's valuable. So we started understanding how this data is often collected. We found there are huge differences. For example, this is Broadway in New York City. These are two images taken from two different contributors using completely different approaches. One mounted a dash cam in a car while driving and imaging in the direction of the road, while another one took a dash cam and oriented it to the left and recorded the left view. And as a result, we have completely different kinds of images, even though we are dealing with the same street. So in our recent research, we have been working on understanding whether this is a problem. Can we still use this kind of data for the same things we are using 360 panoramas from Google Street View? is this data still usable or not? So we conducted an experiment in Singapore. We have taken panoramic images from Google Street View, and we simulated a bunch of different scenarios, how people collect data when crowdsourcing. Like taking an iPhone, collecting data in the direction of driving, or taking a dash cam that has a wide angle and looking on the right side of the road. And then we computed many different use cases using many of these different scenarios and compared their performance with the performance of panoramic imagery. And we conducted a lot of analysis. I will not bother you with the details, but eventually we found that for the most common tasks, like calculating pedestrian greenery or sky view factor, we can get almost the same results like when using panoramic images. So here you can see two maps of Singapore. The left one is showing the sky view factor that has been computed from perspective images. So images taken like from a phone. While the right map shows the sky view factor computed from panoramic images. So the usual way people use Google Street View. And you can see that these two maps look almost exactly the same, meaning that not having panoramic images is actually not really a problem. And this is the first research that demonstrates the value of crowdsourced data. And we hope that thanks to these findings, we will encourage the community to look more into this kind of data. And that brings me to an open data project that we have released last year, which is another attempt to contribute to the community to make it easier to use this data. So in the last 1 year, we worked on a project called Global Streetscapes. And in this project, we have released a data set completely openly that contains 10 million street level images taken from around the world. So we found gaps that street view images, they can be everywhere. They can be often of high quality, but they don't have any metadata. So this data can be quite high quality. You can have a high resolution image. You can have the location of the image. You have the timestamp, but you have nothing else. And when you have data from crowdsourced platforms that can be taken from anywhere, from a bicycle or from a car, and taken during any time, that can actually be quite messy. For example, say you are a researcher working on walkability, and usually in street view imagery that is crowdsourced, you can find data taken from cars, you can find data taken from bicycles, you can find them taken from different weather conditions. But if you're working on walkability, it's likely that you would prefer this kind of images and only these kind of images. However, these images are not labeled. And when you have thousands of images, you cannot manually pick which one work for you and which ones are not suitable for you. So in this project, Global Streetscapes, we wanted to fill this gap. So we have downloaded millions of images from crowdsourced platforms from 688 cities around the world. We picked 688 cities because it was Chinese New Year when we were working on this research, designing the methodology. So we wanted to have some kind of a lucky number. So we picked 688. And then we have been working on building models that enrich them with different kinds of labels that could be useful for practitioners in urban informatics. So we picked these 688 cities around the world based on different criteria while trying to ensure balance. In China, we have about 10 cities included. And then when we downloaded these 10 million images, we enriched them with hundreds of labels. So we have sit down in a few meetings and we thought about any possible label that could be useful. like what is the weather in the image, what kind of transportation mode was used, what's the speed limit of the road the image was taken on, and so on. And we came up with about 300 of these labels. Many of these are not from the image itself, but from the location as well. For example, we linked this to OpenStreetMap, and then we inherited attributes from OpenStreetMap, like type of the road, speed limit, and so on. And when we have finished all this, we release this as open data under a liberal license. And anyone can use this for free for any purpose, including commercial ones. And we also release code openly. This is available on Hugging Face. I think in China, Hugging Face is restricted, so we also release this on Baidu Cloud. And our code is also available openly in case you want to include more cities or update the data. So we have developed a reproducible pipeline, thanks to which you can include more cities. So how can this help? If you're working on topics like public open spaces or walkability, you can get exactly the data you need for your study. You can query the data set, filter the images you don't want to have, focusing on those that are suitable for your study. Let's say you're working on parks in Singapore, you want to understand walkability, then thanks to these labels, you can pick only those images that are useful. Then if you're, for example, working on understanding urban vibrancy during the night, our data set allows you to get only images taken during the night. And I know this sounds like very simple, like do we really need like a big project to detect images taken during the night? But trust me, it was actually quite messy to classify images taken during the night because timestamps have been wrong. Then some images have been quite bright because of traffic lights, but are actually taken during the night. So this was surprisingly difficult to. And eventually, we hope to help the community to use Street View imagery more efficiently to get only the images they need, filtering out those that are not suitable. Because we have 688 cities, we think that this could be quite useful to conduct comparative studies between among cities. For example, understanding the distribution and amount of greenery in cities. So you can use our data set out of the box and directly compare cities. By the way, this is my hometown. It always must be included in our research. And yeah, this is a new project, but we are quite happy with the attention we got. For example, Grab, which is a local taxi company in Singapore, started supporting us. They even wrote a blog post about this research. And we hope that you will also find it useful and interesting. And I'm done with this overview. So this is pretty much what we have been busy with in the last few years. It gives you a bit of an overview of the different research trends. But we also like to spend time being active in the community. We don't want only to write papers and so on. So we also want to meaningfully support the development of initiatives like open data, open source software in our community. So together with a few colleagues from around the world, you may recognize some of these names. We are starting a special issue called Open Urban Data Science in the journal Computers, Environment, and Urban Systems, which I think most of you must be familiar with. We want to give more prominence to open source software in our community. So academia is still a bit conservative and traditional. If you do something useful, like writing an open source software that will have thousands of users, it doesn't mean that your boss will appreciate it. It doesn't mean that your university will value it, unless you write a paper about this, of course. So we wanted to support writing papers about open source software. and we started this special issue that will be specifically geared towards software papers. So we want to welcome the community to finally write a paper about their software they have published, and we will welcome it. We have a very long deadline, so there is really no excuse not to submit a paper. You have more than 1 year to write a paper and submit it. And this is not officially yet approved, but it will be announced next month. So I hope you will find this interesting. And together with me, I also have some veterans of open urban data science. Like, you must recognize probably the name of Geoff, who is the developer of OSMNX. I think almost everyone in our community is using his software, and we joined forces on this special issue. Okay, so that brings me to the end. It's time to conclude. It's been almost 1 hour. So I hope this gives you an overview of not only what we have been working on, but also our research agenda. So we started our research group with the promise of covering the entire process from start to end, not only focusing on analytics, but also focusing on topics that support all that, like spatial data quality, spatial data acquisition. And I think that has paid off, because we realize when we bring all these disconnected silos together under the same roof, we can be more efficient, we can be more understanding of each other. So we think that covering the entire geo pipeline can be quite beneficial. And we think that our community should not focus only on analytics, but we should go beyond applications and include all these topics for a better and cohesive research. The second takeaway I'd like to conclude this presentation with is street view imagery. So I know I mentioned it quite a lot today, but we really found it to be truly transformative. And even though there have been hundreds of papers using this data, we still think there are a lot of opportunities to take it forward. There's still lots of use cases that can be developed. And most of the community has been using commercial data or government data. We are pushing for crowdsourced data, not to replace this kind of data, but to supplement. We think that government data, commercial data, crowdsourced data, they all go well together. They complement each other. And we think there is a lot of value of adding crowdsourced data to the mix. And we think that the future is bright, that it will grow in importance and availability. Okay, so I don't want to take more of your time. I'd like to conclude here, and I will welcome questions. Thank you very much.
Well, thanks very much. You can take seats if you like. Yeah. All right. Well, thank you very much. This is a wonderful talk, because I saw Philip's works and seminars several times in different scenarios. So I recognize this, and this is another version. And to summarize and highlight another topic, that how we use the kind of working processes to make it more scientific, and how this contributes to kind of scientific applications. So we have to pay more attention to the data quality, processing, and with the whole processes, how the result can be calibrated or generated. Normally, I think there's lots of kind of applications that papers emerged using this kind of data. For the planning students, or for in the planning reality, sometimes the planners are struggling of believing in which kind of results or which kind of tools. So this is a very typical struggle sometimes. So I think this is Philip gave his feedbacks on some of this. So we're ready for kind of more questions. Is anyone can have a question? Yeah, please.
Okay, so first of all, thank you very much for the talk. It was very interesting. I've made 2 questions. The first is about the ground vector, like with the buildings. Like, how does it actually work? Is it based on AI, or how does it, like, what information is it based on, and like how does it predict? And maybe you want to first answer this one?
All right, sure. Let me answer that one. Let me just go back. It's been a while. Very early. Yes, this one. Okay. So the whole idea is that we have this phenomenon of data asymmetry in the built environment. For example, streets are mapped often much better than building footprints. And all these features are interrelated. And with GenMapper, we have been working on modeling this relationship. To answer your question specifically, we use generative adversarial networks. This research has actually been a while ago. I think a better approach could be developed today, but back then, GAN was still hot. So we use GAN. Basically, we trained this relationship between building footprints and street networks in places where we have both. And then we have trained this in places with different morphological settings. And then we tested it, how it performs in different settings. Like in North America, we picked a few cities with a typical North American morphology in grids. And we found that the results correspond very well. I mean, not like 100%, obviously, but sufficiently good to support some studies. And I don't want to go like too much into technical details, but here you might also notice on the left column that roads have colors. So we found also that we could train models that take advantage of the type of the road to augment the results. So the input have been images of street networks that indicate not only the urban form, but also the type of the roads. So the input in GenMapper was the image you see in the left column, road network with distinguished road type. So I'm not a computer scientist. I must confess, this is almost like a black box to me. But this is how the black box works.
And the second one is, I mean, you mentioned how the crowdsourced data can have a great quality, but sometimes it's not as good as the commercial one. And then I wonder, maybe also because it's not a standard construct. You showed the how's it, adaptation for like, for example, sky blue. But then I think if we base like on crowdsourced data, maybe it's not always like the same angle.
Yeah,
it's not always like the same sky blue. So maybe like.
Yeah, you're absolutely right. So quality in crowdsourced data in general. I know your question is more on street view imagery. But yeah, heterogeneity of crowdsourced data has been a long topic for like more than 10 years, especially with the popularity of OpenStreetMap. We have situations like this, completely disconnected and uncoordinated initiatives. You have some street where someone decides to map buildings, and then in a district next to it, there is nothing mapped. So heterogeneous data has been quite an important topic that has been affecting also street view imagery that is crowdsourced. And you're absolutely right about these issues, and that's precisely the reason why we started this project. So we wanted to use existing geospatial data quality assessment standards to assess what is the quality of these images. And some of the usual quality elements that people use is completeness. For example, if something is mapped, or if something has been mapped but shouldn't be there. But then we found that when it comes to street view imagery, there is an additional layer of complexity that these standards don't support. For example, exactly what you mentioned, we can have images that are not pointing straight but pointing down, which is not something that users would appreciate. But even though it's something that looks like straightforward, something that should be accounted for, it has never been taken into consideration by standards like ISO 100. So in this project, we spent hours looking manually into images, and we have identified everything that can go wrong with this data. Not only people misaligning their cameras, but also having images that are out of focus, or taking data during a storm, so you have blurry images. Or we also identified issues like lack of blurred faces. So all these platforms and commercial platforms like Google and Baidu, they mask faces for privacy. However, their algorithms are not perfect, meaning that some faces are left unmasked. And this is also a quality issue we have identified that has never been regarded in this standard here. And we came up with 48 quality elements, and the one you mentioned is just one of these 48. But yeah, heterogeneous data is a perennial problem in volunteer geographic information. It affects any kind of crowdsourced data, not only OpenStreetMap, not only this, but any kind of crowdsourced data.
So let me just put in order. So
thank you, Professor. And I have two general questions. The first one is about how to set a suitable benchmark for data prediction works for validation, as many works predicting the actual tuning functions with great characteristics and other things. So how to set a suitable benchmark for validation is data. The second one is more open about the future potential, such as utilizing street view imageries, like employing virtual language models or large language models to whether judge or analyze these complex imageries of different categories and enhance the data set and so on. And as it is convenient to use, but may lack interpretability for further processing.
Oh, okay. So the first question was about finding the ground truth. In most of GIS research, is quite simple. You just take the ground truth, like I just shown the mapper. In much of the research, validation and understanding reliability of approaches is quite simple. You just take the prediction and compare it to the ground truth, like we've done here. But your question is quite topical and valuable because that's exactly a gap we noticed with street view imagery. Street view imagery often unlocks completely new use cases and completely new perspectives, and there is no benchmark, there is no ground truth to compare it with. Pedestrian level greenery is, I think, the best example. So we can use street view imagery and measure how much greenery people see from the pedestrian point of view. And this is the first and only approach to do this. And there is no ground truth for this. We cannot use satellite imagery for this. We cannot use data collected from another source for this. So indeed, this is something that we have been struggling a bit with, because often in studies that use new kinds of data, new kinds of approaches, there is simple no ground truth that we can use to gauge the reliability of such data. So we've been working quite a lot on quality and reliability, but this is not really a problem we have solved so far. It's a bit difficult to set the benchmark for some of these studies. And I think Green View Index is one of the best examples, because street view imagery is a completely new approach to compute it. It's the first such approach, and there is no ground truth to compare it with. So we actually don't know how accurate are these studies. Second, you ask about LLMs. So of course, like many research groups around the world, we are also jumping on the bandwagon and trying to work on LLMs to understand what are the new applications. So far, I don't think we have any paper out yet on this. We have a preprint. We have used LLMs in conjunction with street view imagery. I don't have an example here, unfortunately, to extract data on buildings. So we have built an automated approach that identifies specific buildings, images, and infers 4 attributes: number of floors, type of the building, material of the building, and year of construction. So this is something we use LLM for. It was useful, but also we have been experimenting with other use cases, and we actually didn't find LLMs so useful. So far, our impressions are a bit mixed. Somewhere it can be quite useful, but in some other use cases like perception, we were not really impressed with the results. So we asked LLMs, how do you feel about this street? Does it make you depressed or safe? And of course, the machine doesn't have feelings. We compare it to human ratings, and I don't think we were impressed with the performance.
Yeah, I have two questions. The first one is a detailed question, and if we get to the microclimate part, I'd like to know about the scales of each blocks of the 15.
So this is only an illustration. It's not based on a real case, but I can move on to this slide. This is the scale of our campus. I think it's 1 square kilometer in total.
So how about each small blocks?
You mean the cells? I think this is H3 level 10. I think it's like 58 meters. I would have to check, but it's below 100 meters as far as I know.
And what's the factor to choose the scales of this block and the cells?
Okay. I wasn't the one making this decision. This is not my paper. So we, in the last few years, we started using the Uber H3 global grid system because we wanted to harmonize our studies so we can link them together. And H3 has, I think, 19 different levels of resolutions. And in most of our studies at the urban scale, we focus on levels 8, 9, or 10. I think this is the finest one, level 10. For example, the one on the left is level 8. So we don't really have like some very sophisticated or clever approach how to choose this, just depending on what works.
So, and my second question is, I saw that today's lecture is more focuses on the perception and assessment of the urban place. I wonder if there's any recommendations on the research of the city to, for example, to go back to the page of the physical chain. We have 6 groups. Yes, the cluster chains.
Not the cluster chains, yeah.
And I wonder if there any research on how these factors could be influential on the changes of the factors, and can we give any definitions about whether it's sustainable or lifestyle under this change, or is getting worse, better, and what factors are there influential, and could we make these factors, especially manual factors and artificial factors, to refine them into the actual measures for the future? I think maybe that's kind of usage of the status.
Okay, yeah, sure. But just one caveat, this research is still work in progress. We don't have much published on this, but I can share what we have done so far. So first of all, worse or better, it's a bit relative. And these clusters are not intended to be sequential, they're rather intended to be nominal. So we have these 6 clusters that are not ranked, they're simply clusters. It much depends how you interpret them. And the slide you ask about simply indicates when a street has changed so much that they move from one cluster to another. Now, based on how you interpret this cluster, depends how you consider it better or worse. But in our latest work that we just published in CUS a few months ago, we have been running perception studies. This was based on place pools. And we simply calculated what is the perception score in 2 images across different dimensions like wealthiness, safety. And then we have identified those that have improved or worsened. But we didn't really work that much on explaining the results, on understanding why some of them have worsened. We have done that for only some limited examples. Like in this case, the pavement has worsened a bit. So we interpreted that to be the main reason for this change. But yeah, I get your question, but we didn't really work on this yet so much that I can answer it fully. We don't have yet comprehensive examples. So far, we focus on the straightforward topics, but like detecting major changes only, but without really explaining them.
Thank you.
Thank you, Professor.
Sorry, we'll do it one by one. Okay, please.
Professor, for your lecture. Actually, I have 2 questions. The first one is a small one. Can you go back to the microclimate region? Yes. As far as I know, when we do a machine learning model, we need the amounts maybe less 100 data for the training. And I just asked my friends studying in US, how much station in US camps. He answered me 20. So
40 actually.
40. So the first question is, how can that less data to train this model and can it to predict more the climate data when used machine?
Yeah, you're right. Thanks. Actually, on top of these 40 weather stations, we also bought a mobile weather station that has wheels. So we could bring it to as many places as we wanted. And it helped us to collect a lot of training and validation data.
And the second question is, actually, I have doubts. The accuracy and the efficiency of the street view images 7 months ago. So we made experiments next to the tower, in this tower we got a vision room. So we use the install device to show the panorama video, and we make a compare to let the volunteers do street view images, questionnaire, and the normal video, and of course the panorama video to do their feeling report. And we discovered that when people in a panorama states, they usually experience fluctuate intensely, but when they do the questionnaire with the static images, they usually feel calm and safe. So I think it's a really interesting point to study the quality of the arranged data instead of the algorithms, the statistic analysis method. We should go back to the back to the data. So I want to ask, have Professor you ever think of to do some research guide for researchers in the future when they do the image research, how or should I say what kind of research they could do, what kind of images, and maybe the panorama images or just the normal images is okay.
Yeah, thanks. That's a really good question. We definitely lack more papers on the topic. Lots of researchers have been conducting a lot of these studies, but without ever critically questioning, are they doing the right thing? How reliable is the study? And your question is very timely because we published a paper just last week on guidelines on conducting perception studies. So it was a paper published in Landscape and Urban Planning. It presents guidelines, how many people you need to have in such a study, what kind of rating approach you have to use. And also what you mentioned, is it better to use panoramic images or perspective images? So your question comes to the right moment because we just published such a paper. But I acknowledge that this is just one bit of things we have to investigate in our domain, because we focus on only one use case and we focus on only a few parameters. But there's so many other use cases and parameters that remain under investigated. This is a good example, like Skyview factor. You will see thousands of papers published on calculating the Skyview factor with 3D imagery, but there is no paper on guidelines. There is no paper that actually goes on the street level and compares these results with the ground measurements. So there is much more to do on this topic. But yeah, please check out this paper we just published. It doesn't include videos that you mentioned. It includes only images, but I think it may be related to what you're interested in.
Thank you. A specific question on identifying the mixed functions of the open data. Many studies have identified a single function of the release or qualitatively identify the mixed functions based on UI, remote sensing, and so on. I think it's meaningful to distinguish the specific proportion of mixed functions of the building further. But sometimes it's hard to accurately distinguish the proportion of functions simply through POI and SUI. For example, a single tower building with hotels and offices that has a uniform glass facade. And I'd like to ask if there are any methods or we can introduce other urban data to achieve this.
Yeah, thanks. This is a really good question. It's exactly what one of the PhD students I'm supervising in my lab has been working on. I suggested him to work on that. He wasn't really happy with my suggestion because it's a bit of a challenging problem. But eventually he did a bit of work on that. He didn't really work on understanding the proportions because it's quite challenging. First of all, I think this is a good slide to explain this. In street view imagery, you cannot have a complete overview of the building. You can only infer so much. Let's look at this building. We have a tree here, and immediately you cannot really you cannot infer what's happening on the first few floors, and maybe exactly on these first few floors you have a cafe or restaurant, and on top of that you have residential use. So far, what we have done is only understanding if building is mixed use or single use, but going further, like mapping the exact proportion of uses, mapping the list of uses, I don't think street view imagery could help with that. Maybe it could help only for a limited subset of buildings, those that are fully visible, but in the built environment, for most of the buildings, when you look at street view imagery, you can only cover a small subset of the building. So yes, we did work a bit on this, but it's still a long way to infer data like that, especially proportions. I don't think street view imagery could help with obtaining reliable data on that. Could help maybe verifying data, but mapping buildings from scratch, I don't think so. We did publish this preprint a few weeks ago. It's called Open Facade. We worked on just identifying mixed use, but not really going into detail. Maybe you might want to be interested to have a look at that.
So I'm running a master thesis about the 15-minute city, and I'm like assessing or even algorithm the best way to get to POIs. And I'm just thinking maybe this is already happening. I just don't know about it. But I could also be used to like kind of calculate the best quality way for pedestrians.
Yes, absolutely. This has been done by several researchers before us. Basically, I think even like companies like Baidu and Google are implementing these features in their prototypes. They calculate how much shade or how much greenery is available on different routes, and they've been developing algorithms to find the most comfortable route. So the shortest route is not necessarily always like the most comfortable one. And people will be willing to walk a bit longer if the path is shaded or more green. We didn't really work that much on that topic. This is, I think, the only paper we published on that, where we investigated what people see when they walk on different paths, but we didn't really work on optimization. However, this has been published by some researchers some years ago. I cannot really tell specific papers, but it has already been done.
Very much for your presentation. We have two small questions. First about what you talk about the spatial temporal analysis of the urban environment. Do you find some certain urban elements in the image which are more sensitive indicators of the urban change?
Okay, that's a tough one. This is still work in progress. So also, unfortunately, my answer can only be limited. Earlier. So yes, you can use street view imagery to detect almost like any visual change. And obviously, like the most significant ones would be like you have a new building constructed or a building demolished, or you have a street that didn't have any tree and suddenly has trees. So answering your question, this would be like the most like obvious things. However, at the same time, we don't really need street view imagery for that. We can simply use satellite images and other existing approaches. So what we are mostly interested when it comes to this topic is understanding what can we detect with street view imagery that we cannot detect with satellite imagery. So yes, you can certainly detect things like new buildings, but we don't need to use street view imagery for that. We already have a lot of research done using traditional data like satellite images. So our research is mostly focusing on some subtle changes, some small changes that happened but cannot be detected with traditional approaches like point clouds or satellite images.
So we really need to focus on small changes other than the.
Yes, because I don't really see much value in using street view imagery for something that we already have a well-established approach using satellite images, for example. Yes, you can certainly use street view imagery to detect a new building, but why would you do that when you already have satellite images for that?
And I have another question about the quality source, especially the open data software view the machinery. It's really useful for us to get the pictures, but I wonder that there is unavoidable that there will be some uneven between the spatial and temporal because we need our volunteer to provide the image to us. But I think it may be a long time for us to collect very complex and comprehensive and continuous data. So I wonder how to address this issue about nowadays maybe some not very enough or uneven data for our companies.
Yeah, that's exactly what is a major problem with crowdsourced data. Any kind of crowdsourced data, not only MapReality, but also OpenStreetMap. The completeness and coverage are quite heterogeneous. And this is something that we have been working on. For example, this map here shows when was the last image collected. For example, here you have a road, and you have images from the last 1 or 2 years. So just like a few meters away, you have outdated images from like 5 or 6 years ago. So heterogeneous completeness and coverage is always like an unavoidable problem with crowdsourced data, and it much depends on the use case if this is really a problem. For example, perhaps for some use cases, you don't really need to have all the streets imaged. For example, if you want to calculate the average amount of greenery in a city, maybe you don't really need all streets to be imaged. Maybe the subset that is imaged is perhaps enough to give you, to be sufficiently representative to give you a good result. So yes, it's a concern for some use cases, but for some use cases, it's not really a problem. This is definitely an area that needs more research. We have not done much on this. We have only worked on understanding what is the heterogeneous completeness and coverage, making maps like this, understanding patterns, understanding contributor activity, but we have a gap on understanding how this affects use case.
Okay, is there any questions here? Well, we do have a question for the online.
Oh,
because this has been broadcast and
sure.
usually. So, Songqi, could you ask one or two questions on behalf of them? Some of people were sent advertisements.
Okay.
So the question is, in your research against Ghana matter, the question is there some bias, like they can't predict the cities in China with the data from the sample. So is there some limits that they should predict zero is the neighborhood areas, like they are near to each other, and maybe how can they ensure the accuracy when generating the building filter prints from the provided data? So that's the question.
Okay, so we have tested this on different morphologies, and it performed surprisingly well across different types of morphology, like those that you can find in North America, those you can find in Europe, like organic forms, and also those that you can find in Southeast Asia. So I think it will scale well within the same country. For example, if you have one city very well mapped, and you have another city where you want to apply this technique that has a similar morphology, I think it will perform well. However, if you don't have ground truth, we cannot simply measure the performance. We only validated this approach using cities where we already have good ground truth. There's a typical machine learning problem. If you apply it somewhere, if you deploy your model somewhere where you don't have ground truth, there isn't really any way to validate the results, I guess.
Is there any question? Neil, you want to help me?
Okay.
Or in fact, want to have an end?
Okay. Yeah. First of all, thank you for your nice story going over it. And I come up with a very general and short question. So, have you, or is it possible to consider to integrate the information released from the street view region and integrate them with 3D model, 3D models, and to come up with some promising applications in other areas?
Oh, so we did work a bit on the intersection of building data, including 3D data and 3D imagery. The first research we had was 3 or 4 years ago on generating LOD1 models. So we developed an approach that uses a single street view image to generate a 3D block model. That was an interesting experiment. So that could be one of the use. Another relatively obvious use would be to take advantage of images to produce textual models. We didn't work on that, but I see it as one of the obvious applications. And last year, we have introduced a new use case at this intersection. It's about the perception of architecture. So we use imagery of buildings to measure how people feel about different architectures. And we conducted a large-scale survey with hundreds of people involving hundreds of buildings, thanks to which we train a machine learning model to predict how people perceive every single building in a city, of course, those for which you have images. And then we have calculated the scores, which we have integrated in a 3D model. So we have integrated the visual human perception of architecture at the building level and integrated it in a 3D model as an attribute. So this is something that we have done at the intersection of these two. And finally, it is this open facade project that I just mentioned. We just released a preprint. It's about extracting attributes of buildings like age, material, building type, mixed use, and integrating it into a 2D or 3D dataset. So these are a few papers we have done at that intersection, but I think there is much more to explore, especially in the domain of photogrammetry, to really generate the geometry and the textures. But we are not really working in photogrammetry, so we stay away from that.
Okay.
Maybe collaborate idea.
Yeah, that's well. I do have a question, but I just want to. But I haven't have an answer already, to be honest.
Okay.
Well, I think it's just last year. I think it's when Inlong has. I think they just published a paper in Annals. It's about using the image to detect or identify the so-called disorder.
Physical disorder.
Physical disorder.
Yeah, that was really important paper.
We haven't discussed a lot about why we talk about the ugliness rather than the beautiness of the data. Because it's simply because when we talk about the beauty or good, it's relatively divergent. Yes. Particularly if you ask the experts, so they have a different way to being good. But if you ask them what is really bad, they have a very kind of a more consensus all the time. So that is the reason why, and this is also the reason why Inlong has go to detect the kind of the ugliness rather than the beautiness. But several years ago, when I was in UCL, Steve Law and I and one of his people from Alan Turing Institute, we have a using way to identify the beautiness or the loveliness of the public space using the photo as well. At that time, and we didn't use many kind of a street view, but we just flip the data. So this is a very early age of using. We also use the model to detect whether people will open their shop with the so-called active frontage. So at that time, and I think maybe 8 years ago, so we'll pay more attention on that kind of a phenomena. So I have my answers about why you select and why we select, and looking at the ground truth with more consensus rather than looking at something that is not kind of agreeing with all the people. But I have a question here. It's a very typical questions. How can we get at the causal relationships in this kind of research? Because we are criticized a bit in planning school sometimes, because it's all works. I mean, all my own works is for knowing. Yeah. But they want to have some making process. So my question is about, do you think that's any kind of a possibility that can unfold the black box?
Yeah, so
a bit.
Yeah, that's a very good question. We started getting more into survey design. So in the research I just mentioned, we look into like difference between panoramic and perspective images. But then as part of that research, we have also been thinking how phrasing the questions affect the responses.
Yeah.
And indeed, like more beautiful or less ugly is exactly something that we have been discussing about investigating. Unfortunately, we couldn't investigate it. There were so many other things. But yeah, we found that to be one unexplored research direction. You would get probably different results if you ask people which street feels less ugly comparing to which street feels more beautiful. There is certainly an influence of that.
Yep.
But one of the major gaps that people don't really talk about, which we identified, is not only the grammar that you phrase the questions with, but it's also the language. So we have been deploying some surveys around the world, for example, in South America, and we had to translate our surveys to Spanish. And then we found that the same English question, like which of these two streets feels less ugly or more beautiful, doesn't sound the same like in Spanish. So when you translate it like to a different language, you lose a bit of a meaning, which necessitates researching this topic, like what is actually the proper way to phrase all this so you can obtain consistent results.
Yeah.
So I don't know the answer because we didn't do that yet, but it's definitely something that must be done.
So good. Okay. Thanks.
Yeah, thanks also for those online. Thank you.
Yeah. And thanks for everyone. Thanks for the again. And it is wonderful. And also thanks for everyone. It is a wonderful discussion as well. So we will close today's talk, and I think just a future collaboration will continue. So anyone just interested in Philip's works or Philip's groups, you can just drop emails and messages to Philip's.
Yeah, visit our website as well. Yeah, indeed. Thanks a lot for the questions. I'm actually on holiday, so I didn't expect to go around.
Yeah.
But thanks.
So it's a kind of a brand.
Really stimulating. Thank you. Yeah.
Yes. So thanks everyone. We'll see you next round.